Hello, everyone. My name is Luca Schrot, and I'm the chairperson of the European Regional Office of IPSF, and I'm very pleased to welcome you tonight to the first day of the EuRO Pharmacy Science Week webinars on the behalf of our entire team. Now, through this next hour and a half or so, you will be able to hear two presentations by two different prominent individuals, and I do hope you will learn many new and interesting things. After each presentation, you will be able to ask questions, and you can do so when the chat will be enabled to you, and all you have to do is just click to send your message to organizers only, after which we will select a couple of questions depending on how much time we have and ask those to the presenters. Also, I kindly ask you to ensure that your microphone remains muted throughout the entire session. And last but definitely not least, I wish you a very pleasant evening in our company, and I will now pass the word to Dalia, who will be moderating the sessions. And once again, have a great evening with us. Thank you.
Thank you, Luca, and welcome everyone. Just let me introduce you our first speaker who will kick off this webinar sessions. It is Ms. Miranda Sertic, who works as assistant professor at Faculty of Pharmacy and Biochemistry in Croatia. She is also chairperson of a Young Pharmacist group at FIP. She will talk about science of safe medicines and dietary supplements. This is a great opportunity to hear more about this interesting analysis and their even more intriguing outcomes. Besides all of that, you can hear how the day in the office looks when you're a university professor, scientist, and FIP Young Pharmacist Group chairperson. And now I will give the presenting rights to Ms. Sertic. So you will be able to see at your screen, please share your screen and your PowerPoint presentation, and also you can turn your camera on.
Thank you, Dalia, for your kind introduction. Good evening, everyone. It is a pleasure to be a part of this webinar, and I would like to thank the organizers once again for inviting me to share my experience as being a woman, a pharmacist, and a scientist with you today. Today's lecture is on science of safe medicines and dietary supplements. But to give you a brief overview of what I will be talking about this evening is I will give you an introduction on who I am, what I do, how my typical working day looks like, and the science behind the safe medicines and dietary supplements. So, who I am. My name is Miranda Sertic. I live in Zagreb, Croatia, who has been voted the best Christmas market 2 years in a row, so I hope you can come and join us next year to participate in this great festival. I'm also a pharmacist. I graduated in 2006. I worked in a community pharmacy and then passed my state exam. And then I went back to the Faculty of Pharmacy and Biochemistry, where I completed my PhD thesis on the topic of new capillary electrophoresis and chromatographic methods for the analysis of statins. Down you can see on this slide some of the things which are very important when you say that you are a scientist. So I will share them with you. I'm a co-author of 14 scientific papers in leading international journals. I've written over 30 articles in professional journals. I have participated in national and international congresses with over 60 abstracts. I gave several invited lectures at international conferences and more than 30 scientific and professional lectures. I'm an assistant professor. I teach at several courses at graduate and postgraduate level. I've co-authored 2 textbooks, mentored 20 diploma theses, and co-mentored 9 more. I'm also the president of Junior Pharmacist Group in Croatia, which gives me great pleasure, and I'm the FIP chairperson of Young Pharmacist Group for this year. I'm also a wife and a mother of 2. So how does my typical working day look? I put these 2 photos because I think it kind of shares with you how my day looks like. So it is a combination of my stationary work and a lot of phone calls, a lot of organizing, and also the work I do in a lab. Being a teacher means that I coordinate students' lab work. I give lectures and seminars. I mentor diploma thesis. I'm a part of a very big number of committees and working groups who are very diverse in their topic, number, frequency. But it is also something that, although it takes a lot of your time, I believe is very important. I would like to emphasize, for example, being a part of organizing committee of the Congress of Pharmacists, being a part of the committee for ethical issues at the Croatian Chamber of Pharmacists, or part of the committee for the improvement of pharmacy practice. Now let's talk about science, because that's why we're here this evening. What does science mean? Well, for me, it means that it starts with scientific papers. So you have to know your background. You have to read quite a lot, and then go and do your own research, and hopefully you will end up writing a brilliant paper that will get published in a fantastic scientific journal. So now I will get a little bit technical with you. I hope it won't be too much. I will talk about the science behind the safety of medicines and dietary supplements, and I hope that I will share my passion with this part of science, just a small part, with you, and maybe intrigue some of you to become a scientist also. When we talk about dietary supplements, I'm quite sure that there is not a person among you who has not used them at some point of their life, at least some kind of vitamin. But if you want to define it, then it's a substance with a nutritional or physiological effect that provides nutrients to you. If you look at this slide, you can see that dietary supplements are somewhere between food and pharmaceuticals. It is very important not to talk about dietary supplements and treatment of disease, but we can talk about the prevention. When we talk about medicines, then we are today quite sure that the quality, safety, and efficacy of a medicine is ensured. The quality control monitoring is something that is so strict, so regular, so emphasized in the pharmaceutical industry that a product cannot enter a market without being safe and effective. If you had a privilege of visiting any kind of pharmaceutical factory, but not just a half-an-hour visit, but actually work there, then you will see how much regular testing of quality there is. And when we talk about testing of quality, it actually means that we talk about the identification and determination of active compounds, but also of different kind of impurities in those medicines. So it's not just about making sure that you have the right drug in the right amount, it's also about controlling every possible impurity that can be in your product. When you go and talk about dietary supplements, then it means that the legislation throughout the world is not uniform, and the legislation is actually under food, not under medicines. So unfortunately, when you're talking about dietary supplements, it means that the health safety, the nutritional value, the lab control is not always present. What that actually means is that if you look at the label on your product and it says, for example, vitamin A 3% or iron 3 milligrams, that you cannot be completely sure that it actually is like that inside in your product. Some research suggests that there is 25% of dietary supplements who have some type of quality problem. Either they do not have the active ingredient at all, or they do, but at a too low amount, lower than it's labeled. There are many dietary supplements who are actually spiked with prescription drugs. And if you're thinking who would do that, then think of weight loss products and men's health issue products. There's also the problem of contamination with heavy metals and pesticides. This is just to show you how many recall of dietary supplements that contain sibutramine were found and showed on the FDA page. So it's a whole list, and this is just one point at a time. Also, the erectile dysfunction, which is a very popular product. So you have those natural products, but you actually add a medicine to it, and then you have a very functional product. So I'm not saying that every product is like that. God forbid, it's not like that, but there are many products who simply do lack the quality that is required. This is again just a slide to show you the different organizations, whether it's FDA, World Health Organization, or some kind of other, will show these kind of retractions or warnings that there is a product who has some quality control issue. But I wanted to emphasize to you that when we are talking about dietary supplements, these products are more often used than medicines. They are used on a daily basis. They are consumed by children, by pregnant women, by old people. And in most cases, they are used without the advice of a doctor, without the prescription, and sometimes even without the advice of the pharmacist. If you take that into account, then I hope you realize that the quality control of these products is of great importance. So that's where we come in. What we do at the Department of Analytics and Control of Medicines is the identification and quantification of active compounds and impurities. So we're basically playing CSI in our lab. How do we do that? We use advanced analytical techniques. There are separation techniques, e.g. HPLC, so high-performance liquid chromatography, gas chromatography, or capillary electrophoresis. So I will now give you only two examples that I hope will show you how we do it and what kind of results we obtained in our research. So the first example is ethanolic extracts and tinctures, which are all registered as dietary supplements. So when you think of dietary supplements that are manufactured, then you have to have some kind of organic solvent. If you think of different herbal preparations, then again you have to think of the extraction solvent. I hope that you would all consider using ethanol prior to, for example, benzene as such a solvent. But in every ethanol, you will always find some amount of methanol. It is the most common volatile impurity in ethanol. And by European Pharmacopoeia, which gives you guidance how your medicines should be controlled, the method of choice is gas chromatography with direct injection. What we did, we used headspace sample injector instead of direct injection. Let's talk about methanol just for a second to emphasize you the importance of controlling methanol level in your product. So methanol is a depressant of the central nervous system. It has some very toxic metabolites. It can cause complete blindness, hypoxia, vomiting, and it can even lead to death. The limit for methanol in liquid extract and tinctures is 0.05%. So please remember this number when we look at the results afterwards. Our goal was to develop a new method for determination of methanol as the main volatile impurity in ethanolic tinctures and extracts. So we did that by using headspace sampler gas chromatography flame ionization detector. We chose different samples that were available in our community pharmacist. You can see that there was children's cough syrup, there was some different tinctures, drops, propolis products, and here's a chromatogram. So you can see a very big ethanol peak. Why is it so big? Because the ethanol was used as the extraction solvent. And here you can see the small methanol peak. So remember, you will probably always find some methanol when you have ethanol, but the question is how much? So here are the results of the Croatian jury, if anybody still watches EuRO. So if you look at these results, one of these products, unfortunately, has over the permitted level of 0.05%. So this product actually should not be at the market. Of course, the level of 0.05 is far below than toxic level that would lead to death, but nevertheless, if you're discussing quality of this product, it should not be on the market. So to conclude this little research, you can see that methanol is present in all of the analyzed dietary supplements, and in one product, methanol content was above the permitted level. Case number 2 is red yeast rice dietary supplements. Now, this research is something from my PhD thesis. It was a part of it. I hope that all of you have heard about red yeast rice. It's a natural product that helps you lower your cholesterol levels. I don't think that talking about cholesterol levels needs additional explanation. We all know that cardiovascular diseases are the leading cause of death in the world. And there are numerous products of red yeast rice available on the market. You can buy them in your community pharmacy. You can also buy them online, unfortunately. Red yeast rice is obtained by the fermentation of ordinary rice. You could basically eat it with a mold, Monascus purpureus, and you get this kind of red yeast rice that you can again eat as food, but you can also make some kind of extraction for it and use it as a dietary supplement. There are numerous ingredients in red yeast rice, but we will focus on these monacolins that actually have this cholesterol lowering effect. So this is a slide, just a brief glance into history to show you that back in '79 there was a Japanese scientist gentleman who discovered LOVASTATIN. So it was basically the first statin drug, and he isolated it from a different mold called Penicillium citrinum. At the same time, he isolated MONACOLINK from Monascus ruber. On the other side of the world, another pharmaceutical company called Merck discovered mevinolin and patented it as LOVASTATIN. After that, several statin drugs came into the world, and atorvastatin was one of the blockbusters, making billions of dollars to its company. Beside the monocolin products which have this cholesterol lowering effect, there is also something called citrinin. This is a toxic byproduct which unfortunately is hepatotoxic and nephrotoxic. So the same yeast that makes the good monocolins can also make this less good citrinin. In the European Union, the permitted level of citrinin is 100 ppb. It can be found in grains, cheese, but also it could be found in reduced rice products. So when we saw that, we considered that even the dietary supplements that we all have and sell and use from our community pharmacies could actually have something that is completely toxic as part of as an ingredient. So our goal was to develop a new method for simultaneous determination of lovastatin lactone, lovastatin acid form, and citrinin in various red yeast rice dietary supplements. So we played a little bit CSI investigation, and we used a very nice machine that's called high performance liquid chromatography coupled to diode array detector, fluorescence detector, electrospray ionization, ion trap mass detector. I hope that this name doesn't scare you. It's a very nice machine that provides you a lot of very good information and some very interesting results. So this is a chromatogram. I hope that somewhere during the course of your pharmacy education you had the opportunity to see this. So this is a chromatogram obtained by a UV, a DAD detector, and this is basically lovastatin or monacolin. So it's the same natural occurring drug that is both patent as a medicine but also present in a dietary supplement. This, however, is a chromatogram obtained by a fluorescence detector where you can see the toxic citrinin. This is a chromatogram obtained by the mass spectrometer. So as you can see, there is a lot of more noise, a lot more peaks, a lot of more information that you can gain from a mass spectrometer. It sees more things, but it's also very selective, so you have the ability to just select the analytes of your interest and deal with them. So that's what we did actually. We took a look at the lovastatin lactone form. So I won't go into details of the spectrometry, but just to give you a glance of what we did, the science behind the safety of these products. So you do MS analysis of the analytes of your interest. 405 is actually the molecular ion of lovastatin lactone form. This is MS spectra. So you put some energy into it and your molecule breaks. So you lose this ester part and then you have 3 as your leading signal. You can do that even further. So this is MS spectra. So your molecule, after losing the ester form, also loses water, and this lactone ring opens up. Here you can again see different fragments. To know these kind of fragments is very important because by knowing this fragmentation pattern, you can later identify other components, other monocolins that could be present in your product. This is exactly what we did, and we're able to find and identify 3 different monocolins in some of our analyzed products. And here are the results. So take a look first at this column. So you can see that the toxic citrinin was found in 2 products. This one actually very close to the permitted level of 100 ppb. I would also like to put your emphasis to this column. This column shows you the result of what was detected in the product the quantity that was found versus the quantity that was labeled. So this column should state 100%. So what was labeled was supposed to be in the product. As you can see, none of the analyzed samples had this ratio corresponding to 100%. In fact, the ratio was between 2% and 157%. So nowhere near what was labeled. These two didn't label anything, so they could not make a mistake because they did not claim the amount of the active ingredient in their product. So to conclude, dietary supplements are used on a daily basis. There are such a vast spectra of products, and they're used more often than medicines. It's constantly given to children, to pregnant women, to old people. And remember, people do not go to doctor for advice. People do not even always ask the pharmacist for advice. So we have to make sure that the quality of this product is very good. That's why we do what we do here at our Department of Analytics and Control of Medicines. We develop new analytical methods that will enable you to identify and quantify both the active compounds and impurities. So, thinking of science behind safe medicines and dietary supplements, you can be CSI, you can be just the pharmacist, but you can contribute, you can make a difference. I would like to point out that based on these results, actually, there was a company in Croatia that actually implemented our methods into their products for red yeast rice because they want to make sure that their products that they put to the market are of high quality. And when you see something like that, then you do know that the science you do actually matter, that you do make a difference in the end. So to take a home message, yes, we are pharmacists and we care for our patients. And I hope you didn't fall asleep. I hope I was interesting to you. I hope that what I do interests you in science and that some of you will choose a science career for themselves. I would like to thank you all for your attention and once again the organizers for inviting me to participate.
Thank you, Ms. Sertic, and of course we didn't fall asleep. Thank you again for this wonderful lecture. And now I would like to just say that chat box is open for participants, and you can write down your questions. And do not forget to send organizers only. Until then, I have the first question to open this Q&A section. So, since you are a chairperson of Young Pharmacists group at FIP, do you have any advice why to join and what are the benefits, and also how students can get more involved into the organization?
Thank you, Dalia. Yes, I think this is the most often question I get asked about FIP. What are the benefits? Why should you join? And I like to bounce the ball back to them and ask them, why did you join your local student organizations? Why are you a member of IPSF? What do you gain? And I try to make them think that what you gain from organizations like that is what you grab for. So the opportunities are numerous. There is so much that you can benefit from, but you have to make that step. You have to reach out and grab it. So, for example, you organized this webinar this evening, but if you as students did not participate, if you did not log in, then of course you did not benefit from IPSF in any way. It's something like that with FIP. Going to the FIP World Congress is such a huge opportunity. There is so much people there that you meet. There is so much different pharmacy, actually. It amazed me when I went to my first FIP Congress, because you see that although everybody has the same goal, and this is the care for the patient, of course there are differences around the world, but these differences are so intriguing. I think they give you so many ideas of what you can implement maybe in your daily work, in your daily practice. The network you gain, the friendships you make, I believe these are for life, and becoming young professionals, this is such a great opportunity to have people from all around the world. How to get involved? Well, just keep working with the IPSF. I'm proud to say that the Young Pharmacist group this year is working on research project that we invited IPSF to join in on us, and I would like to say that the students working on this project are our hardest workers, and I would like to congratulate them and thank them and encourage all of you to join in. There is not a limit. You can be both members of IPSF and FIP, so I hope you do consider. I hope you come to Seoul in September this year to the FIP Congress. The opportunities are amazing. They judge you, but by what you do, by how much you try. So my first Congress was actually in Düsseldorf in Germany in 2015, and I worked for a year. I volunteered. I asked, is there a project I can join in? And I ended up organizing the first timers meeting for Buenos Aires conference in 2016. And I was elected the chairperson of YPG at my second Congress. And this is coming from a very small Croatia, so it's not like I had a lot of support from my home state. So they actually judge you but by what you do. So I don't think there are any limits. I think you should all join and just bring all the potential you have, bring all the enthusiasm you have, bring all the ideas and the hard work you already put in your daily work.
Thank you for your wonderful answer. So we have the questions from our participants. So the first question is, what is the difference between mass spectroscopy and mass spectroscopy 3?
Okay, so it's the question is, I think, the difference between the spectra, mass spectra, and MS3 spectra.
Yes.
So MS gives you the spectra of your molecule. You should be able to see the molecular ion of your molecule. The MS3 spectra means that you put some energy, that your molecule breaks, then you grab that molecule, the ion you get, and then you break it again. So you get fragments. These fragments help you to make the puzzle when you have to identify something that you do not know the name of, the structure of, when it's an unknown ingredient. Then the fragments help you to come to a solution and actually identify the ingredient. I hope this answers the question of our attendee.
I hope it does. So one more question. So we have another one. Did you check red yeast rice products for any other toxin beside citrinin?
No, not at this point. We did citrinin because it was interesting, because it was produced as a byproduct by the same yeast that actually produces the monocolinks with the cholesterol lowering effect. Of course, you could analyze these products for any other mycotoxins like ochratoxin, any pesticides that could be used on the rice, any heavy metals. But this is a part of a whole different research, so it was not done as a part of this PhD thesis.
Okay, thank you. I hope that this answer is enough for our questionnaire. So one more question. If the diet supplements legislation isn't the same for everyone, why don't the authorities remedy this by establishing new rules or something like that?
So thankfully now in Europe we do have a legislation that is the same for all member countries, and a lot of emphasis has actually been put so far to the labeling and to advertising. So you cannot say anything for your products. If you looked at them before, then you could put all kinds of statements on these products. They help you with your health, they will cure you, they will stop this, prevent this. Now that has to be evidence-based, and for every product, or better yet for every ingredient, you have a list of the statements that can be put on the label. However, the quality control of the product itself still remains a challenge. I know it's very challenging for the legislation and for the producers, because this is, when you look at a dietary supplement, a natural dietary supplement, a plant has thousands of ingredients. It's very difficult to control all of them, to identify and quantify them. But that being said, I would like to remember all of you that 60 years ago, the quality of medicines was not as it was today. And after the disaster of thalidomide that happened to the world, today it is impossible for a drug to enter the market without numerous tests that ensure the safety. I hope that in 50 years or even sooner, we will talk the same way about dietary supplements.
Thank you for the answer. So questions keep arriving. So I have one more. What is the advantage of the mass spectroscopy versus NMR spectroscopy?
Okay, so although MS is very expensive, NMR is even more expensive. But yeah, they give you some kind of different information. MS is usually hyphened to liquid chromatography or gas chromatography, so you have a separation before them, and then you have online identification. For NMR, it's not a separation technique. You have to isolate each component and then analyze it to obtain some structure. So it's a different approach, I would say, completely.
Thank you again. And one more question is, I wanted to ask you how a company implements your new method into their regular procedures. For example, what is needed, requirements, how much it takes, and so on.
If you're referring to the example I gave about the red yeast rice product, so since it's a dietary supplement, it's actually up to the producer to do the analysis or not. They wanted to make sure that their product was very good before putting it into market. We published our results, so the method we did is public. You can go online and you can look it up. And in terms of that, we share our knowledge, so we're here for you to do the research and then for you to use the method. So for them, they just implemented the method to their lab to make sure as hard as they can that the product they put on the market is of high quality.
Thank you for your answer. And we have the last question of the night. So it's thank you very much for the webinar. I found it very interesting and enlightening. So if I wanted to get into regulatory affairs for a medicine control authority or pharmaceutical company, what would you say I should study after my pharmacy degree?
Okay, so I don't know the country of the person this question came from, but in Croatia, the pharmacy degree is a 5-year degree, and you actually can go straight to regulatory affairs after this. But if you're coming from a country which is organized in a different way, the pharmacy curriculum, then you should probably just check with your school and maybe just send an email to your regulatory affair institution. Maybe some countries would require some kind of specialization, 1-year or 2-year program. So I think it depends on your country.
So, Ms. Sertic, thank you again for being the lecturer, and see you. Thank you.
Thank you. Thank you. Bye.
Bye.